हॉरिजॉन्टल कर लो टास्क।
ठीक है, it's better now. Screen सही है,
यस
ठीक हो गया. Okay, so last time हमने basically I wrote down some of the laws of nature. Well, I did not write them down explicitly because I could not. I had some issues. Lekin we started with the familiar expression for force, which was F is equal to the time derivative of some quantity of motion as Newton described it, but now we call it momentum. And we talked about this. हमने इसके meanings क्या हैं, इसके ऊपर थोड़ी सी discussion की थी. And then I wrote down a couple more laws of conservation laws for physics. And then we saw the low velocity limits of these laws, from which we also arrived at F is equal to ma. And then we talked about collision. Specifically, we talked about perfectly elastic collision, and we tried to understand why is it called a perfectly elastic collision as well. And then we looked at motion of the system, and from that we saw some laws for energy and work done. So where I also talked about conservative forces and non-conservative forces, and one of you had a question ke usko thoda sa matlab elaborate kar dein. So I'll try to do that today, but I will continue from where I left yesterday, and फिर हम conservative or non-conservative forces पे end पे बात करेंगे, right? So I stressed upon this thing that to understand physics, you need to do a lot of examples. And I even gave you one example to understand this thing that you have to do examples, right? Where I talked about the ancient way of doing mathematics, at least, or physics. So, and I ended off with saying that some of you might think that physics can be simply done by just plugging in formulae, and it's not going to work, right? So now I'll give you an example. I have designed a problem. I'll give you that example to show you that it cannot be, you cannot solve a problem by just simply using formulas, right? You need to have some feeling for what's actually happening for a real situation, right? So I'm going to write down a problem. I'm going to draw it. And while I'm solving the problem, while I'm analyzing the problem, I want you all to think about it, how I'm analyzing it. And if you can figure out the mistake that I would be doing in the analysis, because that there I would not be using physics, but I would just blindly follow the mathematics, right? And you can point out if you find the problem, and let me know as well, right? Okay, so let's start. Say, suppose we have a machine and it has two rods connected to it by a pivot. So these are two rods, and they're something like this. And to this rod, you have a roller, and it can slide in such a way that it can go over here and it can move over there. So it can move in this one-dimensional motion. And you have another one, but this one is fixed with this pivot over here, and it's not allowed to move, right? And at top of this, you actually have a weight attached, something like this, right? So it has a big weight on it, and the this end of this rod is connected to the floor by a pivot, right? Okay, so the roller is going to move back and forth, and it's going to be in such a motion that it will make sure that this weight would go either up or it would go down, right? So I hope you can understand the working of this machine. So if the roller move towards right, the weight would go up, and if the roller moved towards left, the weight would go down. So now let's say that the weight of this of this object attached on top is, let's say the mass of this thing is 2 kilograms, and the rods, each of them is 0.5 meters long, right? And at a certain moment when the machine is it's standing still, the distance from the weight to the floor, let's say this distance is 0.4 meters. Now you can easily use the Pythagorean theorem, and you could calculate this distance. And so it would be, well, this part would be 0.3 meters, and this would be also 0.3 meters. Right. Now, the problem is to figure out what is the horizontal push that is required on this specific roller. And let's call that push, let's call it P vector. We have to figure out what horizontal push is required so that you can hold the weight up, right? So you have to hold the weight up. So you have to just apply enough amount of force on this roller to keep it there. Now, I'm going to make an assumption that we would be needing in order to solve this particular problem. और वो ये है कि when the rod has pivot at both ends, in that case, the forces or the net force is always directed along the direction of the rod, right? Okay, so well, we also know some more from information from physics, and well, that's actually from Newton's law, that the forces are equal and opposite at the end of these rods. What I mean by that is whatever force is exerted by the rod on the roller must also be exerted by the rod on the weight, but of course in the opposite direction, right? Okay, so now, well, I'm just going to use these ideas about the properties of rods, and I'll try to figure out कि horizontal force या ये horizontal push क्या होना चाहिए, right? Okay, so let's say I'll go about this problem in such a way okay, let's see this horizontal force exerted on the roller by the rod would be a certain component of the net force that is acting on it, right? And that would be the x component, right? So I get the components of the force exerted by the rod on the roller. In particular, let's say that this the horizontal component that I want, if I can get the components of this force that are exerted by the rod on the weight, right? Okay, so now let's try to draw a free body diagram of the situation. Or yeah, let me just quickly do it over here. So let's say this is our weight, and these are two rods. One is connected to a roller that can move, and the other one is connected to a pivoted roller. And this distance is 0.4 meters. This one is 0.5 meters, right? And let's resolve the forces along this weight, right? Okay, now, like I said, that there would be a force in this direction that would be F. So if I call the horizontal force on the weight, that would be Fx, this one. Then the horizontal force on the roller should be negative f of x, right? So that would be like this over here, because you have to remember that these forces, this f is like this, and so this f from Newton's law would be minus F, right? And the force that is needed to hold the weight up is simply the equal force, this one, negative Fx, right? But in the opposite direction, so I can say that this P vector should, or the magnitude of this vector is Fx component, right? For the vertical force जो weight के ऊपर है rod की वजह से, that is Fy, this one, it's actually very easy, right? Because it's just the mass of the weight times the acceleration that is due to gravity. So it's simply F is equal to, or let's say Fy is equal to mass of the weight m times g. And so I said that the mass is, well, let me remember, see, yeah, I called it 2 kilograms. So 2 kilograms times 9.8, this would give you 19.6 newtons, right? So that's the Fy component. So the vertical force on the roller would be equal but opposite, again from Newton's third law, and it would be negative 19.6 newtons, right? So now the question is that how can I get the horizontal force if Fy, the y component of the force, is 19.6 newtons and the net force always lies along the rod, right? Because we said that we had to make an assumption कि हमारी जो forces हैं, अगर हमारी pivots हैं both ends पे, तो force हमेशा along the rod होगी. So फिर how much should f of or this Fx component should be? So that's what we have to figure out. So I did not hear anyone pointing out the mistake that I'm making, so I'm just going to continue.
Sorry.
And
Sorry.
yes,
Can I ask him? Shouldn't the
yeah.
vector magnitude be equal to df over dt? Sorry, dp over dt equal to f of x or something, because
Oh, no. No, and not like, which one are you talking about? This Fy?
uh, no, above the f of x is equal to magnitude of p. Like
This
the
is not
piece.
momentum, by the way. This P
Oh,
is the force, that is the
oh,
horizontal force. इसको
oh,
मुझे P नहीं
okay.
कहना चाहिए था, but
Yeah, I was
I
confused by
wrote it
that.
P. It's push, right? So it's the I wrote P for it because it's a push. It's the force जो हमें calculate करनी है, जो push हम इसको करें तो जो हमारा weight है वो ऊपर ही रहे,
Okay,
right? ठीक है?
thank you.
Okay. So okay, now I'll just use a very simple trick from mathematics, and it's the projection of triangles to evaluate this Fx component. And it is okay such that the जो ratio है horizontal to vertical sides का वो because you can see that this would form similar triangles, right? ठीक है, ये जो components हैं ये similar triangles बना रहे हैं. So the जो ratio होगी horizontal to vertical side, it would simply be 3:4, right? Because this one is 0.3 meters, so 3:4, right? Horizontal to vertical, right? And then again, due to similar triangles, this would be the same as the ratio of as Fx is to Fy, right? So I can write Fx over Fy is equal to 0.3 over 0.4, right? I hope you understand कि यहाँ पे हमने क्या किया. If you don't, you can ask, right?
Yes.
Okay, perfect. Now we have already figured out what the vertical force is, right? We have figured out what Fy is, and that's 19.6 newtons. So I'll just simply substitute this 19.6 Newton in here, and this set this equal to 0.3. Well, it's 0.3 meters over 0.4 meters. And all I have to do is I'll bring this over here, तो वो multiply हो जाएगा, तो fx क्या आएगा हमारे पास? If you do this calculation, you get 14.7 newtons. And if you remember that what was P, if I go back here, I said कि magnitude of P जो है वो equal to fx के बराबर होगा. We saw that. And so now I can say कि we conclude that कि हमारी जो horizontal force है on the roller needed to hold the weight up वो 14.7 newtons है. And that's the answer to our problem. But is it, right? Because I said I will make a mistake, and I was expecting some of you might or any one of you might point that out. But you see, like I stressed in the previous lecture, you can't simply do physics just by plugging in the formulas. You will not really get anywhere with it. So you have to have something else beside just knowing the rules. And these rules are what I'm calling mathematics, right? The formulas for projections and all this stuff. So you have to have a certain feeling of the real situation. And in this particular problem, the difficulty is that the net force on the weight is not only from one rod, right? हमने तो सिर्फ इस rod को consider किया. But what about this one? Of course, उसका भी कोई role होगा that we did not consider the whole system basically. So there is also force exerted on the weight by another rod, and it is in the same direction. And I previously जब अभी मैंने किया इसको, I completely ignored that, right? I ignored that during all my analysis, and so it's all wrong basically. So now the thing is that I also have to worry about the force that the rod with the stationary pivot, जो ये वाली rod है, exerts on the weight. So now it seems like कि हमारा problem थोड़ा complicated हो रहा है. And the question is now कि how can I figure out what that force is, right? जो इस rod की वजह से लग रही है. What is the net force of everything on the weight? Can somebody tell me that? कि जो weight है इसके ऊपर the net force क्या है सारी चीजों की मिला के?
0.
No, not really.
It has a f of x component, but f of y is equal to 0.
Yeah, it is something like that. It's actually just gravity, right? And it just balances the gravity. And there is no force horizontally on the weight. And this is where जो हमारा clue है ना इसको solve करने का problem वो यहाँ पे हमें पता चल. क्योंकि the clue is by which we can find out just how much, well, say juice there is along this rod. मतलब कितना component है force का along that rod. जिसका pivot stationary, right? So मतलब this one, because that's the one we're talking about. So that is कि it must exert, बस उसे इतनी force exert करनी है कि वो horizontally balance कर ले जो दूसरी rod force exert कर रही है. And then we can say कि हमारा जो weight है वो ऊपर एक जगह पे रुका रहेगा, right? Okay. So now if I would have to draw a completely new free body diagram, because this one as well, it's actually completely wrong. So if I were to draw the force that the rod with the stationary pivot exerts, its horizontal components would be exactly opposite the horizontal component that the rod with the roller exerts, right? And the vertical components will be equal, and that's because of this similar triangles. Now let me actually draw this thing pehle. So again, we have this weight over here. It's attached with two rods. There is a roller that can move, and here's the roller that cannot move. And it's 2 kilograms. Well, यहाँ पे नहीं लिखते इसको, यहाँ पे हमें components बनाने हैं. तो well, एक हमारे पास यहाँ से यही वाला बनेगा, because the force जो यहाँ पे है वो हमारे पास है negative F, and well, okay, so this one would be negative Fy, this one would be negative Fx, and the force that is along this side, ये हमारे पास जो net force है इधर वो है negative F prime, and I'll tell you what I mean by this, right? ठीक है, I'll just tell you. This one would be negative F y prime, and this would be negative F x prime. Okay, and जो weight के ऊपर forces हैं, ठीक है, वो हम इस तरह लिखेंगे कि यहाँ से इधर भी होगी एक force. So this one would be F, and this force would be it would be F prime. So if I resolve it into components, so this one would be F prime x, this one would be F prime y, or again this one would be fx, and this one would be f y, right? तो जो weight के ऊपर total force ऊपर लग रही है, and this is where the problem was पिछले उसमें, जो ऊपर total force लग रही है वो सिर्फ fy नहीं है, बल्कि it is fy plus
F prime y.
y prime, yeah, and that total force is actually that is balancing out this force, और जो ये हमने calculate की थी, this was 19.6 newtons, right? So again, the vertical components are equal because of the 3, 4, 5 identical triangles. 3, 4, 5 से मतलब ये है कि उनकी जो sides हैं, right? So 0.3, 0.4 and 0.5. That is that both the rods are actually pushing up the same amount, because we know their horizontal components must balance, right? क्योंकि horizontally net force कोई भी नहीं, और vertically जो है वो gravity को balance कर रही है. So well, I would leave a question over here for you as well. You should try it, in fact, कि क्या अगर हमारे पास जो rods हैं उनकी lengths different होती, फिर क्या होता? The whole idea is the same, but you would have to do a bit more of the calculation, because उसमें फिर हमारे पास ये fy और fy prime में थोड़ा सा difference होगा, right? So let's start with the weight again, ठीक है? तो हमने weight के बारे में बात करते हैं, जो weight के ऊपर forces हैं. The forces from the rods on the weight are the first thing जो हमें सबसे पहले इनको सही सीधा कर लेते हैं, ठीक है? So let's look at the forces from the rods on the weight. Or here I would like to also mention something to you, कि the reason I keep repeating this thing, कि the forces from the rod on the weight, because it's important, because otherwise what happens is I tend to get all the signs mixed up in all of this gymnastics, if you might call it, okay? The force from the weight on the rod is the opposite of the force from the rods on the weight. So did you understand that?
Yes.
Okay. Now, So for me, I always seem to have to start over when I get balled up like this. Okay? So and so I have to think it out again and make up my mind again as to what I want to talk about. And I'm certain, of course, some of you might as well, right? So then you might say, then you should say to yourself, okay, well, look at the forces from the rods on the weight. So there is a force F which is in the direction of the rod. Now, if you look at this diagram, there's a force F which is in the direction of the rod. Then there is a force F prime in the direction of the other rod. Now, those are the only two forces, and they are in the directions of the rods, right? Now, the net of these two forces have no horizontal component, but a vertical component of 19.6 newtons, which is from here, right? 19.6 newtons, right? So the horizontal force balances, therefore the vertical components add, and the 19.6 is just not the vertical component of force from one of the rod, but it is also the total force from both is 19.6 newton, right? Because each of the rod is contributing half of it.
Yes.
So the vertical component from the rod with the roller is only 9.8 and not 19.6, right? Now, if I take the same thing, if I just have to do the same thing using this horizontal projection of this force and writing down the ratios in the same way as I did before, I would have Fx to the horizontal to vertical, but this time we know okay, vertical is not 19.6. It is actually half of it, and it's 9.8. And this ratio is again because of the similar triangles, it's equal to 0.3 over 0. It was 4, right? Let me just go up and check. Yeah, this was 0.3 over 0.4. Right. So now if I compute this using, well, it's very simple. So f of x is simply 0.3 over 0.4 into 9.8, and this gives me 7.35 newtons, right? And this is the force that we had to compute, right? And so what it means is कि इतनी हमें force लगानी है horizontally on the roller जो move कर रहा है, जो ये वाला है, horizontally इसको इतना push लगाना है 7.35 newtons का कि हमारा जो weight है वो ऊपर ही रुका रहे, right? So the whole system is in well, equilibrium. Now this example was just to tell you that if you are not careful about the physics of the real situation कि क्या हो रहा है, you can make mistakes, right? So the only way to do problems is don't just use जो formulas आपको आते हैं, आपने एक टेबल में अपने पास बना के लिख लिए होंगे, आप उनको ये नहीं कि ये फॉर्मूला है, इसमें ये चीज है, तो मैं इसको इसमें पुट करके और कैलकुलेट कर लूं. No, it will not work. Sometimes it does work, sometimes it does work, but in the long run it is not going to work. You have to know the physics of the situations, because again, this is a course of physics that you people are studying even at your universities or schools, right? It's not a course of mathematics, right? So I
Can I
hope
ask a question?
yeah, sure.
I was wondering how would our assumptions and the change if the road was massive, like it had a weight, both roads. So would that affect our assumptions, or would they stay the same in this problem?
Oh, well, we are using it would definitely affect the problem, but we are saying the rods are massless, right? Because then there would be some mass that is coming from, even these rollers are, we are considering them massless, right?
Right.
Okay. And so where was I? Acha, hopefully this me doing an example like this gave you some idea about के अगर आप अब कोई problem solve करने लगे तो आप, because ऐसे होता है कि people do think something like this कि हमारे पास ये formula है हम इसको use कर लेते हैं without thinking about the physics. So I hope कि it was helpful to you and you learned something from an example as such, right?
Yes.
Okay, right. Now, okay, so I think it was you who yesterday asked me to elaborate on conservative and non-conservative forces, right?
Yes, it was
Basil?
me.
Yeah. Okay, so I'll go over it today, right now, and I'll also give an example. So let me go to a new page. So, well, conservative force, right? Let's talk about conservative force. So a force जो है वो conservative कब होती है? जब total work done आपका जो on the particle है, that moves from one point to another. So say you have a particle that is moving along this curve from A to B, right? जो total work done है, total work done, it is the same regardless of the path that the particle moves on. So it only these 2 points A and B is what matters. In a simple words, जो distance है ना इन points के बीच में A और B के, वो distance matter करता है. It doesn't matter if you take a path that is something like this or something that's even more wiggly and zigzag. The work done is the same regardless of whatever path it takes. Only the distance between these 2 points is what matters, right? So the total work done depends only on the end points of the path. And so we say that the work done by a conservative force on a particle that goes, आपने इनफैक्ट ये चीज सुनी होगी कि अगर एक पार्टिकल है वो एक सर्कल में जा रहा है, तो अगर जो कंजर्वेटिव फोर्स इसके ऊपर है तो the total work done would be 0, right?
Yes.
Because that's simply because it started at this point A and it came back to this point A, or let's say कि point A और B जो है वो overlap कर रहे हैं एक दूसरे के ऊपर, right? So the distance between these points A and B is simply 0. And so then this integral जो हमने कल किया था, f dot ds would be 0.
Okay.
Right? Okay. So by definition, for a conservative force, the total mechanical energy of the particle is constant, right? And I talked about this also yesterday. So I can write it as कि हमारा जो delta kinetic energy, change in kinetic energy, T represents kinetic energy, plus the change in the potential energy is equal to, what should be equal to? It should be equal to 0, right?
Total
Because
zero. Sorry, zero. Yeah,
yeah,
because
yeah.
total energy is
Uh,
zero. You need no work.
Yeah, because the total mechanical energy of the particle is a constant. The total mechanical energy 0 नहीं है, लेकिन जो change है वो 0 है, right?
Yeah.
Change in the mechanical energy is 0. So from this then I can write down this कि जो initially kinetic energy थी और potential energy थी, as in the total energy initially of the system would be equal to the total energy जो आपके system की at the end है. Sorry, यहाँ पे VF आएगा, right? ठीक है? Yeah, or do you have
Okay.
any problem from me going from this to this?
No, it's clear.
Okay, okay. So this is what we call the conservation of mechanical energy. Now, अब हम एक simple सा problem करते हैं, ठीक है? Let's say a problem is something like this. There's a child, and the child is old enough that it has a noticeable mass m, right? And वो एक water slide ले रहा है, ठीक है? So let me just quickly first draw something. Okay, and this is a water slide. I don't know if I can draw it. Well, consider this that ये एक water slide है, ठीक है? इसमें एक child है, ठीक है? एक बच्चा है छोटा सा, and he's sliding down, and the height from the ground of this slide is let's call it anything. You can call it h. So let's call it h. So now one of the very important thing over here that I would like to mention is that the child is released from a resting position. What that means is that initially the velocity of the child at the top is 0 initially, right? So he's just released. There's no one to push the child. The child is just released from the resting position at the top of the water slide. And let's say that h, or this height, is equal to 8.5 meters above the bottom of the slide. So the bottom of the slide is, let's say it's at the ground. Now note that I can ignore friction, or usually हम problems में friction ignore खुद ही से कर देते हैं, but I designed this problem, or this problem is designed in such a way that there is water on the slide, so the friction would already be very less. So see, I'm clever like that. So let's just find the child's speed at the bottom of the slide, right? अब अगर हम इसके लिए, if we use Newton's laws of motion to find the speed of this child at the bottom, मतलब कि if we use her acceleration along the slide, that would be well, we cannot do that in this specific problem. Can you tell me why? I hope you understand कि मैं question क्या पूछ रहा हूँ.
Sorry, could you repeat your question?
Yeah.
The internet here is a bit.
Oh, okay, okay. I'm just saying that let's say that I want to find her speed at the bottom, right? So can I use her acceleration along the slide and find that with this information कि मुझे बस ये पता है कि इसकी mass क्या है, right? And I know कि ये किस height से release किया उसे, and I also know of course कि initially जो इसकी velocity है वो 0 है. So can I use acceleration along the slide to find out the speed at the bottom?
I suppose not, because the angle is varying, so it would be
Exactly,
difficult.
exactly.
It would be
Yeah,
difficult
yeah,
to.
exactly. Very good, very good point. Very good point. It's because we don't know the slope, and that means we don't know the angle, and it would keep changing every time.
Yes.
और
So
इस वजह से हम न्यूटन्स लॉज नहीं यूज करेंगे, बिकॉज न्यूटन्स लॉज आर अबाउट वेक्टर्स, राइट? बिकॉज फोर्सेस आर वेक्टर्स, एंड सो द वेक्टर जो एक्सेलरेशन वेक्टर है वो हर पॉइंट पे इट वुड बी कीप चेंजिंग, इट वुड बी चेंजिंग, राइट? सो बट वी नो कि जो स्पीड है it is directly, or it is related to the child's kinetic energy जो होगी इसके पास, right? Speed is related to
Yes,
kinetic energy
it's
from half
1
mv
upon
squared.
2 mv square.
Yeah, exactly. So then perhaps I can just use the conservation of mechanical energy. Then we don't need the slope, right?
Right.
Okay.
Right.
So now, well, when can I use the conservation of mechanical energy? That's also a question, right? Can I even use that in this question? ठीक है, मेरे पास एक speed का relation है kinetic energy से, so I can think कि हाँ मैं conservation of mechanical energy use कर लेता हूँ. But then there are some factors that we have to consider, because mechanical energy is only conserved एक ऐसे system में if the system is isolated और उसमें सिर्फ conservative forces लग रही, because for only a conservative force we can define potential or potential energy, right?
Right.
Now, so let's see, let's talk about के इसके ऊपर forces कौन सी लग रही हैं. Can you tell me के what are the forces that are acting on this child?
Gravity and
Yeah,
yeah, gravity, which is
and any
conservative force, and the normal force
uh,
of the child.
yeah, exactly. So there is a gravitational force acting on the child, and there is normal force that is acting on the child. But normal force, is it doing any work on the child
No, no,
for
because
it to?
it's, yeah, no,
Yes,
it's not doing any work because it's
because it,
perpendicular to the, it remains perpendicular to the direction of motion.
yeah, it the normal force will always be
Perpendicular to
perpendicular
the
to the direction of
direction of motion.
motion of the child, right? ठीक हो गया. So by the way, there is one way from which you can also figure out कि आपकी force conservative है या नहीं है, right? So I don't know if you know this, लेकिन I don't think I should even mention कि, but it's if you take a curl, I don't know if you I doubt कि you would know what a curl of a vector is.
I
Have
have
you
studied
ever
a bit of,
seen something like this?
yeah, yeah, the div operator and the
Okay,
divergence
so
and the curl, right?
if you have an idea of this, so I'll just mention this, but of course I will not go into depth of this because of course और भी लोग हैं
Yeah.
जिनको हो सकता है ना पता हो. But if you take a curl of a vector, or let's say if I take curl of the force, and if this curl is equal to 0, तो इसका मतलब है कि मेरी जो force है वो, because if I look back at this, I can convert this integral into del cross f
Yes.
dA.
So
So if del cross f is 0, तो उससे क्या होगा, ये पूरा इंटेग्रल 0 हो जाएगा,
yes.
and the force
So
would be conservative
0.
force.
Yeah, it will be, sorry, it will be conservative force. Yeah.
Yeah, a conservative force. Exactly. Right. Okay. So now let's talk about the system. और हमारा system जो है वो isolated होना चाहिए for the conservation of energy. So for a system to be isolated, इस system में ये जो हमारा पूरा system है, this thing, इसमें सिर्फ gravity work कर रही है, right? Because we said that there are only two forces.
Yes.
One is the gravitational force and the other is normal force. Normal force is not doing any work because it's always perpendicular. So theta हमारे पास 90 हो जाएगा, और
Yes. So it will be 0.
right?
The
So
work done will
it
be 0.
exactly. And the gravitational force is doing all the work now, right? Okay. So because the gravitational force is only doing the work, तो फिर हम अपना जो system है, हमारा पूरा जो system हम consider कर रहे हैं वो सिर्फ हमारा ये child जो slide कर रहा है इसके ऊपर, like this thing, and the gravity or the gravitational force is our system, basically the earth and the gravity of the earth and this part of the system, right?
Right.
So then we can say कि ये हमारा system isolated है from all of the other forces that could have been acting. So if this all of this is true, तो फिर we can use the conservation of mechanical energy, right? And
Right.
we can say कि जो when the child is at the top of this slide, we can say कि उसकी जो mechanical energy है, let's call it some E, let's call it E at the top, so let's call it ET. And जब वो, because we are using the conservation of mechanical energy, it should be equal to the mechanical energy that the child would have at the bottom
Bottom.
of the slide, right? So then this thing should be equal to EB, where E is the mechanical energy and this B just tells you कि वो bottom के ऊपर है, right? ठीक है. Now the total energy हमें पता है वो क्या होती है? It is the sum of the kinetic energy and the
And the
potential
potential
energy.
energy.
Yeah. So I can write down कि ET should be equal to T, जो ये वाला T अब मेरा kinetic energy का T है, right? और ये जो subscript में T है, this says कि it's at the top, the kinetic energy at the top,
Top.
plus the potential energy at the top, and this thing should be equal to the kinetic energy at the bottom plus the plus the potential energy at the bottom of the slide, right? Ab yahan se everything is simple. I just have to plug in this thing. Now we just have to do some mathematics, right? Humne physics apne situation ki samajh liye, right? So I hope you are
Right.
understanding
Yeah,
how we are solving this problem.
it's clear now.
So the kinetic energy at the top would be half m, and velocity at the top squared, plus the potential energy at the top is, you know what is potential energy? It is mass
mgh
times the gravitation and h,
times
right?
the,
So
yeah,
yeah, so but we are looking at this top part. तो top पे हमने इसको ऐसे system को लिया हुआ है कि this is our y axis, right? And it is positive in the up direction, right? So y axis positive है ऊपर की तरफ. अब it's up to us actually. हम इसको I hope you know this. We can take a coordinate system के where this could be y, this could be x, this could, it's totally up to us, right? और हम
right.
एक physics के law को law तभी कहते हैं कि it should remain the same no matter what kind of a
But
coordinate system we choose.
coordinates, it's invariant under any coordinate system.
Yeah, exactly. So I just added that over there just for fun. So this thing should be जो y coordinate है at the top, so let's call it yt, right? And this thing should be equal to tb, kinetic energy at the bottom, so that's half m v at bottom squared, plus the potential energy at the bottom would be mg yb, where yb is the coordinate at the bottom, right? So now all you have to do is, because remember we have to find VB, right? We have to find the speed of the child when he reaches the bottom of the slide. But now we know कि well इसको थोड़ा सा simplify कर लेते हैं पहले. Let's write VB squared जो हमें find करना है, right, is equal to VT squared. We are just rearranging this equation over here, right? Plus 2 times g yt minus yb, right? हमने सिर्फ इस वाली इससे ऊपर जो एक्सप्रेशन है उसको रीअरेंज किया. नाउ vb स्क्वायर्ड, इसका हम स्क्वायर रूट ले लेंगे तो हमारे पास स्पीड एट द बॉटम आ जाएगी. बट नाउ वी हैव टू थिंक अबाउट सम थिंग्स, and that is कि we know कि she was released from the rest position, or she was at rest
Yeah.
and she was released. So what does that mean
Vt is equal to
for
0.
this equation? Yeah, so
Our
this
initial
thing
velocity is
should,
0.
yeah, exactly. So this thing should go to 0, and we know कि हमने अपना जो axis choose की है, y axis, it's positive upwards, so this thing is just equal to h, which should be equal to
8.5.
positive 8.5 meters, right? So I hope you understand sign हम किस तरह हमें पता चल रहा है कि positive use करना है या negative. So
Yeah.
well, then what is VB? Simply just put in the values. The mass would just go away. I hope you know कि यहाँ पे mass cancel हो गया था, right? So
Yeah.
because we had in every term of this expression we have a mass, so it will just go away. Or you can say कि हम mass से divide कर देते हैं पूरी expression को. So VB is simply equal to under root 2 GH, and I think you might have seen this formula before as well. And this thing, just put in the values of G and H, so you would get 13 meters per second.
Yeah.
And this is now the important point over here that you should notice is कि अगर हमारी force कौन सी थी, gravity की force थी, and we know कि it's a conservative force, क्योंकि अगर हम gravitational force का कर लें तो वो हमारे पास 0 आएगा. तो gravitational force, it's a conservative force, so the path should have never even mattered कि वो किस path से जा रहे हैं. अगर वो directly नीचे भी जा रहे हैं तो क्या होना
So
चाहिए?
its velocity would have
Velocity,
been the same. Would have
the
been the same.
velocity should have been the same, and the work done would have been the same,
Same.
right?
All right.
So of course, I'm not an evil kind of a person. I would never just throw a child directly down like that, right? But so that's why we considered I did this particular problem.
Right.
Now I can talk about non-conservative forces as well, thoda sa. So I'll just do it, and I don't know if we will be able to do an example, but I'll just give you an idea of a non-conservative force. A non-conservative force
Uh,
would be,
like
it's up to
it's
you
like
if you
friction, right?
want me to. Exactly. So it's everything that a conservative force is not. So what I mean by that is
Yeah.
कि a
It's
non-conservative force would be the one जहाँ पे जो work done है, it depends on the path that you take.
path. Yeah.
इसका एक आसान सा एक example ये हो सकता है. Well, friction, we know कि a friction is a very good example of it, right? And to demonstrate that, let me just do this thing. Let me draw a circle. I hope that makes us, yes. And let's just fill it with some color. Right. So now I'll just copy paste this. ये क्या हुआ है? Let's copy paste. Okay, so why am I doing this? I'll just tell you, right? If I have 2 points on this circle, ठीक है? Let's say कि हमारा जो goal है वो A से B तक जाना है, ठीक है? Right? So it's same like this. Now if I erase, आप एक पेपर के ऊपर कुछ एक सर्कल से ऐसा बना दो, उसे इरेज करो, तो फोर्स कौन सी होगी उसमें जो उसको इरेज मतलब आपको हेल्प करिए उसको इरेज करने में? देयर इज फ्रिक्शन, राइट? फ्रिक्शन इज
Yeah.
एक्टिंग व्हेन यू आर erasing something off. So if I erase it like this directly, मतलब एक straight path follow किया A से B तक, and
So
what
less
I
energy
could
would
do
be
is I
expended.
could exactly, so or I could do something like this. I could follow this path. मैं गया अभी भी A से B तक ही हूँ, लेकिन इसमें
But
फर्क
path
क्या
matters.
है कि जो एक तो वर्क डन में जो इस तरह आपने अभी कहा है एग्जैक्टली, देयर इज लेस वर्क डन फ्रॉम A to B देन फ्रॉम in this diagram from A to B than in this diagram from A to B. And so in this work done is something like इसको अपने compare कर लिए कि कितना amount कितना erase हुआ है, right? So the amount erased depends on the path that is taken from A to B, and so does the work done that is done against this friction force, right? So less work done is so work done is actually less uh, when the amount erased is less, and vice versa, right? And
Right.
again, like you had already just pointed this out, that less energy would be expended and it cannot be fully recovered, right? It cannot be fully recovered क्योंकि जो most of the work done जो होगा वो thermal energy या heat की तौर पे it would fly off, right? So you
Okay.
cannot
Right.
completely recover that. Even though you might be able to recover most of it, you can never completely recover all of that, right? So the most important characteristic of this is के जो the work done जो non-conservative force करती है, it adds or removes the mechanical energy from the system. And so then this thing that was true for energy initially is the same as energy finally would not be true, right? क्योंकि थर्मल एनर्जी की वजह से आपका जो वो वर्क डन है या इट गोज वर्क डन जो है वो थर्मल एनर्जी में चले जाते हैं, तो आपके सिस्टम की किनेटिक एनर्जी या पोटेंशियल एनर्जी सेम नहीं रहेगी जो वो इनिशियली आपके सिस्टम में थी, राइट? सम ऑफ इट हैज बीन जस्ट लॉस्ट in terms of heat, right?
Right. Yeah.
So then this means for mechanical energy जो है हमारी वो ऐसी नहीं लिखी जा सकती. For mechanical energy there would be an extra term added to it, that is the work done by the non-conservative
Conservative
force.
force.
Exactly. So this I'm going to stop here. Yeah, I have already gone 13 minutes above my time. So
Okay.
yeah, that's it for this मतलब lecture. I hope कि आपको समझ आई
Yeah.
है, and if you have any questions regarding anything that I said, you can ask them now.
Okay.
Or
So can I ask
post them. Yeah.
what topics will we cover next week or in next class?
So in the next
How is
class, uh, because we are talking about dynamics, and there is a lot of things जो आप dynamics में जिनके ऊपर बात कर सकते हैं, right? There is a lot.
yeah.
So
So
it's up to you people कि आपको किन किन टॉपिक्स में इश्यूज हैं, क्योंकि हम तो अगर हम जो पढ़ा रहे हैं, अब हम बहुत सी चीजें हैं जो हम पढ़ा सकते हैं, जो और कुछ चीजें जो मतलब उनमें से एक्सक्लूड भी कर सकते हैं. तो वी
yeah.
नीड टू हैव योर व्हाट डू यू से ओपिनियन कि आपको किस चीज में ज्यादा इशू है जो हम आप चाहते हैं कि हम आपके लिए
So
करें.
can we do gravitation in the next like class if possible? So and Kepler's laws
Yes,
and
we
all
can
that.
do gravitation. वो हम gravitation in fact हम करेंगे भी, because it is we asked you people to vote and gravitation got enough votes, so we included that
Yeah.
in our curriculum.
Yeah.
So we
Okay.
will do gravitation, and
Okay.
hopefully it would be very soon. We also have to cover harmonic oscillator and
Yeah, that's
things.
also
So I hopefully right after harmonic oscillator we can do gravitation, or maybe
yeah.
we we can do gravitation earlier as well if you insist. So हम पहले भी कर लेंगे. There's no
Oh,
issue.
oh, okay. Thank you.
No, no. Any more questions if there are more people in here? Right. So I'll assume nobody else have any more questions.